Okay, 6 p.m. PST. Let's get started. So we have this second review for our midterm, this next day. And is there any question or discussion topic that you want to bring up? Please let me know. Or anything else. It doesn't need to be related to the midterm only. It can be anything.
Oh yeah, I was just wondering for the midterm, are we allowed to print out the Mips screen sheet and then use it during the test?
Yeah, you can. Like this is in addition to your one-pager cheat sheet. You can print. I will provide link though in the midterm quiz. Like in your practice midterm, you have seen probably there is a link to the Mips screen sheet that is loaded. That can be loaded into that lockdown browser. It will be similar during the midterm, but nonetheless, you can take a print copy. That's okay.
Okay, sounds good. And so I don't exactly have A4 paper, so is it okay if I just use regular printer paper as well? For the cheat sheet and the Mips screen sheet?
Yeah. Regular printer paper should be okay.
Okay, all right, thank you so much.
Professor?
Yes, Rahul.
Yeah, for a discussion topic, I was hoping we could talk about the different dot modes, dot extern, dot global main, and what do they do?
Okay, so is it like just related to the dot extern dot global, or do you want more on the dot? Like there are a lot of dot directives in the.
The primary directives what I wanted to want to help it was dot extern, dot main, and dot global.
Dot. What is the second one? Dot.
Dot extern. Dot main.
Dot main. Okay, what is that? I even don't know. Let me see. Did I use it somewhere? Let me see. The dot would be. Okay, I can get it into the Mars probably. Okay, first of all, let me list down on the Jamboard. Okay, you want dot extern, dot global, dot main. Okay, let me study. Let me see what is it. Where did you get that dot main?
Okay, to be honest, I'm not sure if I remember seeing it somewhere or if it just popped up in my head right now. But I was just trying to remember the different ones which I could not understand. I tried to read on my own. Dot extern and dot global were two of them.
I think dot main was on the quiz.
Okay. Dot main. Wow. Okay, let me see. I'm going to the quiz. Quiz number 2, 3. Do you remember?
I'm opening quiz 3 as well right now, just to check if it was there somewhere up there.
Okay, all right.
Professor, I found it what I was looking for. It was question 8 in quiz 3. Dot global var C main.
I think you may have confused main as a label.
Quiz 3. Question number 8. Oh, this is not dot main. This is dot global var C main, right?
Yes. So what is the main over there?
Okay, I can. Okay, what is Oh, main is a text block. Okay, why don't I just cut paste this example on my Jamboard and so that it can be a reference to what we discuss. Okay. All right. Okay, I'm sharing my Jamboard with you guys. Okay. Just one. Okay, so here, we don't have anything dot main, but it is more like a dot global. So, okay, our question is, what is the difference between dot global and dot extern, right? So you see that dot global is followed with label names. These are the label names. Okay. This is one level. So any level, whether it is belongs to the data section or text section, doesn't matter. Main is right there. And if you look at the variable C, so it is right there. So, so each label goes into the symbol table. In terms of symbol table, each label will be part of the symbol table. Like let's say we're doing that as a table, and so we all know by now a symbol table contains the label name and the label address. So in this program, there are I see there are 3 levels. Main and the text and data section has 2 levels, var B and var C. So those will be definitely part of the symbol table. Not necessarily in that order, but I'm just inserting them into the table. B, var C, and it will have some address associated with that. Let's say it is like this. Main was this address, and var B. Let's start from the address 1001.0.0.0.0, and then this guy will be this is a word, right? So this will start from 4. It's a byte. It's from 4. Now let's say what are the other things goes into the symbol table? One is definitely a type of the label. Okay. Let's call it a flag or type. Let's say type. So this one. So any level by default start with a local level. It's a local. Okay. It's a local level we define into the program as a local. And now, when we declare some label with a dot global, this keyword dot global followed by the list of labels, we essentially declaring those labels as a global label in our type in the symbol table. So var B and var C essentially would become a global level. Now let's come to this extern. What this extern really means. So extern creates a global label, okay, and it is instructing the assembler that this is a global label, okay, global can be globally accessed, and reserve 8-byte space for it, 8-byte space for it. So if you look at the Mips hand, that green sheet, it's global, okay, not the Mips. It's in terms of, okay, Mips doesn't distinguish between a global space and extern data space. But remember, we had a discussion with respect to the Mars, where Mars distinguish them, and Mars global data, I believe it starts from one. So let me just check. I'm just opening the Mars and going there. Setting memory configuration. Okay. Okay, extern base address. Okay, is 1000. Okay, all right. So for Mars, what will happen when Mars take this extern var 8, it will create a label, okay, and then it will place the address. It starts from the global space. So for Mars, it is starting from 10000000, this address. So see that our data space for Mars starts from this address 10010000, but extern anything must start from the address in the extern global space, which starts from 10000000. And by default, it marks that label as global. Okay, so and also another distinction of that extern is that you don't need to initialize that memory space. It is just telling that, hey, reserve 8-byte space for this var a. What does it mean is this, like here, for example, in the .data section, you actually initializing that space. You are defining, okay, from this address, which is represented by var b label, place a word with value 45. You need to actually have some initialization code there in the data section. But for the extern part, you don't need any initialization. You just need to tell assembler, hey, reserve this much space, which in turns means, let's say you have another .extern. Let's put some more. We can, I believe it, we can create in one line, but let's not go there. Let's say var x, and let's say now this is 12 byte space, let's say, and another extern var y, let's say it is 4 byte space. So with these entries, what it will happen, first of all, we don't need an initialization, as I mentioned. And in terms of the symbol table, now the symbol table have additional entries.
Professor, before
Yes.
proceeding, shouldn't where be start 8 bytes ahead?
Where we start what?
Shouldn't where be start 8 bytes ahead of where it's currently written in the symbol table? Because where A starts at 000, then where B will have to start from 0008.
No, but you see that where A is starting from 10000.
Oh, that's my bad.
This is a global space, right? In terms of Mars, actually distinguish between these, they call it a static data space or something. Like this goes in a different space of the memory which starts from this address 10010000, and any extern starts from this address and place them onto that part. So that's why, yeah, you don't need to put the same logic. They're in the completely different memory section.
I see.
But within the extern, we need to, we don't need to follow the same concept in the extern, because the extern is telling telling the assembler that reserve that many space for me. It doesn't tell whether it is a word or byte or single word, half word, etc. It doesn't tell. It just tell in terms of byte. Okay, reserve a memory space for me of 8 byte long, right? And then the next extern, let's do them. So
So
that's
is alignment followed in Extern?
alignment is only, okay, alignment is related to the data initialization and data usage. But since like in the extern, you are not saying it is an word type or half word type or byte type. So there is nothing alignment involved at all in that case.
So if we're using externs, then it's possible to have a word of data cross two memory spots. I mean, be stored in two different external memory slots, right?
You
Because
can,
it's not going to be aligned.
but you are not able to access it. Like when you are going to access that address, that time you will get a runtime error
I
saying,
see.
hey, this is out of alignment. That's what I'm saying. It is like, it is extern is much more like you are reserving some memory. Usage is not declared upfront. That how are we going to use that memory? Like, are we going to use that memory from that address as a word or a half word or a byte? It is not even declared at that point. It is just a raw memory that is being reserved for your program, and you will use it as needed. But when you are accessing that part of the memory, you need to follow the alignment rule.
Okay.
Okay.
So both, yeah. So if a word of data does cross between two memory slots, then you need to read two memory slots and then combine the information from
Yeah,
one and the other to get it.
exactly. If you want to go with that complexity.
I
Yes.
see.
Okay, now this is extern. So it will be on that 100 space, and it will be starting from the 9th byte, which is like 8. And then this guy is reserving 12 from there. So 12 means it will span up to 20, and then next address for var y, it will be marked as, it will be 10 is 16, 11, 12, 13, 14. No, wait a minute. 12 plus, yeah, that's fine. I think that's fine. Let me just cross check with the calculator. This is x. One zero 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 0008 plus 20 plus 20 plus 20 is 1C. It seems like that's what this is 1C. So you add this address and 20 on top of that, your hex become, oh, why am I adding 20 by the way? No, just hold on. I need to add 10, right? Let me redo. 10000008 plus 12. 100A. 1A. Okay, so var y would be 1A. So we add 12 on top of this address, which will give you 10000001A. So your variable Y address will be starting from that in the global data space for the Mars. So essentially the difference between about .global and .extern is that .global is to make any existing local label as a global. Okay. But .extern by default, you are defining a global level, and moreover, you don't need a memory initialization part. You are just reserving that many bytes for your program usage. Okay, these are two main differences. Is that okay, Rahul and others?
I see that. I see. All right, but Professor, I just want to continue on this. Could you explain the rest part on the first line, like global var c main? What does that line mean? Is it saying that label? Is it saying that in variable c, I mean in var c store main, or initialize it to main? Like, what does
It's
that
just a
mean?
list. You're just putting a list. You could have,
Oh, it's a okay. It's a list.
yeah. So you could have done like this, like .varc dot global main.
You can just have multiple of them on in a list. All right, I see.
Yeah, 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 yeah. That
Professor,
is just a
I have two questions.
yes.
So the first was, why is main at 0x04? Is that like just a preset thing, or?
That's a power up address. We need to look at. I just put some numbers there. Let me see. Yeah, it's if you look at the Mips green sheet,
Yeah.
it's basically 0040. That's what it is. Share again.
So main is set at 0040, but then
Yeah.
the var c was set at 1001. Or yeah, wait.
Main is
C is a global, right?
C is a global, but we are declaring that level as global, but it is still here in the.
Oh, I see. Because then you put it
Your
in the data.
Mars will still put it as a from this memory space from 1001.
Okay. So is global does global start at 004?
Dot global, no, dot global is not starting any address. It is just declaring some label to be a global. So it is basically operating on this type column.
Oh, and then main was just 004 because that's where you put it below.
Yeah.
Okay.
So your address computation has nothing to do with global or local. Like it's basically that address space, right?
Yeah.
Any text part, right?
Yeah,
will
I see that
be
now.
placed in this from this address, and any data part will be placed for Mars. It will be placed from 1001. Any of this data section. Extern for Mars starts at this point.
Yeah.
For Mips convention, it is the static data, right? But for Mars, what they did, it kind of reserved this entire space for the extern usage. And then after that, it started another memory space, I think from 1001 till, okay, why don't I bring up my Mars again? Just hold on, I'll show you. This is your Mars. Go to the memory configuration. See, look at here. So your extern base address is starting from 10000, and it goes all the way till 1000 FFFF. Then dot database address starts from here, goes all the way till 1003 FFFF, because after that it starts the heap of base address, which is the dynamic part of the memory. So this one, what I mean. So here Mips convention was start the dynamic part from 10008000, but Mars start it from 10040000. Okay, and it basically reserved the below part till 100800 from 1001 from this address till this address is reserved for the any data section, dot data. So that's why, oops, that's why we have placed this here, right? More precisely, like if question has to be more precise, it has to be like this. It's better, it starts with some, oops. So this is of no confusion. If some program is given like this, dot data and start address of the data segment, there is no confusion where you place the first label on the data section. Okay. Main doesn't have, okay, let me see. Main has the same concept here. Text 00400. Okay, Mars text and Mips recommended text starts from the same address, so no conflict there. So in the exam, right? If something is not given like this. Okay, so let's just take this example. If it was given this one, you can start from this address. Okay, you can start placing them from this address. No worry about that. Only in case of Mars, this guy differentiate between a dot data segment and an extern segment. Okay.
All right. There was also one more thing that I think I might have missed.
Mm-hmm.
For your var y, why is there like an extra 6? When it says 1a, that's 26, right?
1a is 26. Did I make a calculation mistake? Let me just see. Okay, so var a was from this address, right? And then if you add 8 on top of this, it is this, plus 12 on top of this, it is this, right? So
wait, Professor, isn't that adding 1, 2 in hex?
Yeah.
Okay,
So
that
you
makes
12 was
should be
added in
adding
hex.
E.
right,
Yeah.
right. Plus, I should have done this 8 plus 12. Oh, then I was correct in
All right.
1-4. Thank you very much for catching that. Yeah. Right. Okay, so these are the mystery of the dot global and dot extern.
I see, Professor. Professor, I want to continue on that thing because over here in the table that you drew, you listed main as a global label,
Mhm.
but then in the same quiz, main is not like once the answer are revealed, main is not a global level in that same quiz question.
Okay, let me see that. What was the question? The question was in this following code, which are the global data levels? Main is not your data level, main is a text level,
Oh, I see.
right? I asked for the data levels, not the text level.
I see. That's it. Hi, man.
Okay, what else?
Hi, Professor.
Yes.
I have a question for the quiz 3, question 9, for the one to get the machine code instruction. I have problem to how to get the machine code.
This one, right? It was like more, yeah, it was what we need to do here. Let me, why don't I just copy it? I kind of discussed this last day, probably you missed it. Not this specific question, but in general, how we can make a BNE of these. So in general, what we need to do, where is my here? Let me share. Okay. Okay. Text. So we were given that to get a machine code of this kind. Which one? Loop. Instruction at level loop, which is this one, right? BNE. So BNE, of course, like this is like I type, right? So our we have to keep track of the opcode, which is 5. You can get it from the Mips screen sheet, and that is in the hex 6-bit. It is 000101, and then it says T0 and 0, right? And now you need to look at the Mips screen sheet page. First page towards the right hand side lower corner, it has a register name and numbers, that table. So I can see the 0 is 0 and T0 is 8. T0 is 8. So your BNE mnemonics is this: BNE RS RT level. So that is the format of the assembly code, RS, RT. So that means in this instruction, your RS is T0, which is by number it is 8, and RT is 0, which is by number 0. Okay, so that means we know what is my RS field. Okay, what is my RS field? Okay, RS is 8, which is a 5-bit field in the format. So it is 01000. RT is 0, which is in 5-bit 00000. And then it comes to the immediate. The question is, what is this immediate field is? In a shortcut, all right, immediate field is like a instruction offset from this instruction. However, there is a catch there. You have to distinguish between a forward jump from that point. Sorry, this is a backward jump, and a forward jump, okay, from that point. So let's classify. This one is towards the end. So this is a backward jump, right? This is a backward jump. So there is no forward jump. This is a backward jump from that point. For forward jump, index is basically you count the number of instructions from that point. So this is like, oops, this is like instruction offset 1, 2, 3, 4, right? 1, 2, 3, 4, and 5, right? This is where we are jumping. So our instruction offset, this is +1, +2, +3, +4, +5. Now for the forward jump, you need to subtract 1 from it. So that's why you basically count that instruction offset 5 and subtract 1 if it is a forward jump. So this is 4. Now 4 in 16-bit, it's basically what? 000, 000, 000, 000, 0100. Right? Then we can calculate the machine code as let's place this bits 0 0 1 0 1 0 1 0 0 0 0 0 0 0 0, and then rest of this guy.
Professor, sorry to interrupt, but
Yeah,
are there supposed to be 3 zeros after the 1?
3 zeros after the 1.
For immediate
maybe-
4.
Yeah. I
I think you have an extra 0.
Oh, okay,
yeah.
okay. This one, right? This is correct, right? Thank you very much. Thank you. So now we partition them to 4-bit each. 4. So my machine code in hex would become like 1 5.
Professor, for the R-type instructions, are the register T and register S swapped? I mean I-type, not R-type.
I-type instruction, yes, yes. So basically, if it is a test and jump for BNE, it is RSRT. It's you can see it in the instruction set. If you consult that, the app, what is that, lecture 10, 11, those pages from your book. Look at that. Look at the BNE instruction. It is different than the add. Let me come to that one. Okay, let me first complete this one. This is 1 5 0 0 0 0 0 4. Are they 32-bit? 1 2 3 4 5 6 7 8. Okay, so this becomes your hex machine code for that. Just to note, if it was a backward jump, like from these to there, you don't need that. You basically need to do a +1, right? +1 on top of that. Let me see. We did that one. So we discussed that if it was a L2 was a forward jump. In that case, it was a 3. So 1, 2, 3, 4 -1 +3. But if it was a reverse jump, then instruction count was -1, -2, -3, -4. And then we need to do one more subtraction. Okay. So if it was a reverse jump, you count the instruction in a reverse, like negative order, -1, -2, -3, -4, and go one more after that. Okay. It becomes like -5 in this case. All right. Is that clear?
Yes, yes. Thank you very much.
Okay, now coming to the Rahul's question. So if you look at the set of instruction formats and all these, like lecture 10, lecture 11 shows, BNE format mnemonics is like this, whereas for example, add I is of this format, RTRS level. Rahul, did you find it? Let me see if I can bring it up.
I see. Okay, so that order does depend on which operation is being used rather than I-type or R-type.
Exactly. This is where the assembler assumption is, like what you putting where, right? I think it was in lecture 10 and lecture 11.
Actually, Professor, no need to find that. I'll check that out later for myself.
Yeah, since I'm here, let me just, why don't I just, yeah, this is, see, all the add-I is RTRS immediate, whereas if you look at the jump, rest and jump, it should be here. See, like B equal is RSRT. The order is reversed for branch and test on this. Okay, so that's what played here, that role.
Neat. I see. Professor, I've got 2 more questions.
Yes, tell me. Oh, before you go to that, sorry, I realized that I didn't share that document. So add I is RTRS immediate. whereas BNE B equal kind of is RSRT by the assembler convention. So that's what that is playing that role of which one to take where, which place. Okay. All right, Rahul, go ahead.
Yeah. The next question.
Mhm.
Could you repeat the convention for the push and pop? What comes first? Is it the storage first and then move the pointer, or move the pointer and then storage?
For our class, it is write the data into the stack first and then move the pointer.
I see. Write the data and then move the pointer.
Yeah, just as in we described in our, I think, this lecture.
And when we are writing the data, we are writing the data wherever the stack pointer currently is, not 4 bytes displaced ahead.
Yes, whatever the current stack pointer we're writing at that place.
Okay, so ideally by convention, the stack pointer should always be pointing towards an empty slot. That's like what we're trying to do.
Exactly. Yes.
I see. Neat. Then
Yeah, so exactly this slide, right? Lecture 9. Slide number 16, which shows us store the data first and then decrease the stack pointer. On the pop side, this is our convention. First increase the stack pointer and then load the data.
I see. So, Professor, in question 18, we had to select true statements, and this statement was not selected as the solution says the statement is not true. And the statement was push in Mips always needs to store data first and then move the stack pointer to the free address. In this situation, is it the case that
What is the
because the
question
statement says always that it's false?
Hey, what is the question number?
Question number 18 in quiz 2.
Quiz 2. Okay, let me just open that. Quiz 2. Okay, so you're saying that why this is not a correct statement, a true statement. Push in Mips always need to store the data first, then move. It is not always.
Or, yeah, okay, that's what I was thinking. It's because the statement says always that's false.
Exactly, right? This is kind of, Mips doesn't force for any convention. It is just our class that is following one convention. Other convention is also true. It
I
is
see.
more like
Wait,
that.
so it's not a MIP suggested convention, it's just that we are using that convention.
Right, exactly.
Okay.
Mips
But
doesn't.
then the
Mhm.
but then the stack memory and the heap memory and I mean the data storage slots, those are MIP suggested conventions.
Those are Mips suggested convention, and again, like some system can actually like defy that convention. Okay, what does it mean in terms of what is these conventions are? Like these conventions for the Mips point of view, saying that when you switch on the Mips processor, when you first turn on the Mips processor, your counters, your register, program counter, global pointer, and stack pointer are initialized to that that value. That is a power up address values. Okay. Now, after that, what you do with those memory part, you can you can actually go away from that convention and use your own convention if you like. But in most cases, we kind of stick to that convention. We don't want to override the power up register values at the very beginning when the system is booting up. Right? So that's the thing. But you can, like, one system designer can decide to go away from that convention and use the other convention, any other convention. Anything is valid. in this space. It is more like, like discussion of who is right, big Indian convention or little Indian convention,
I see.
right? Neither of them is wrong. Both of them are right. Just follow one.
All right. And I've got well, yeah, okay, one more question.
Mhm.
It's what is the shift amount? There's a shift operator which kind of shifts all, which is with a logical shift, a left shift and a right shift. But then there's also a different shift which is part of the instruction.
So shift instruction is if you look at that Mips green sheet, shift instruction is classified as the R type. Right? Let me go there. Shift left logical SLL R type. Right?
Professor, that's not the shift I'm referring to.
Which one you are referring to?
If you in the R type instruction when it's broken down, yes, basic instruction R type, that's SHAM.
Yeah.
That is
this
shift, right?
Yeah, this is the same thing. So what all it's saying that SLL in that field, you are not able to, or you should not put anything beyond 32 or 31. In fact, 0 to 31 is the right amount of values there. Okay, is a 5-bit value. So I believe in the marks, if you put something like SSL, RD, RS, something like S0, S1, and then followed by a shift amount, which is more than 31, it will become a pseudo instruction, and Mars will do something special by splitting into some basic instructions there.
I see. Okay, so so in the add in our R type instruction of add, the shift amount just automatically is 0.
Exactly, right? So this one is RD, RT, then RS field actually remains 0 in that machine code calculation. If you're worried about that, what to put in the RS in terms of SLL or SRL instruction, since it is not related to the RS field at all, it is operating on RD and RT. RS, you put all zeros there, basically. Okay, and then operate on put right value for the RT, right value for the RD, and right value for the shift amount. And that shift amount in a basic instruction should not exceed beyond 31.
Okay. And why should it not exceed 31?
Because if you shift it 32-bit register, if you shift by let's say 40-bit, what's the result?
0 on both sides. I see.
Right? Anything beyond 31 you go, it's 0. Result is 0.
I see. Okay. Neat. I think that covers the questions, at least from my part.
Okay, this is good discussion. What are the other things? Let me know.
Real quick, how important is it to know the system car codes or the syscar codes? Like, should we have that written down in our cheat sheet sort of
Don't
thing?
need to remember. If you need it, I will give it or if I want you to analyze some code, I will give the meaning of the system call code. No need to.
Okay, thanks. Because it wasn't on the green sheet and it came out a lot in our code. So.
But so it is in the part of the quiz, you mean?
No. I mean, like, I was just doing like the homework and stuff, and then I saw it like come up a lot, and I had to like go search it up or look in my notes each time, and I was just wondering because I couldn't find it in the green sheet either. So.
Oh, okay. No, for exam, if I give that type of question, I usually give the what does it mean, that system call.
All right, sure, thank you.
No need to. If it is not, you can just come to my Zoom session and ask me if I miss that.
All right.
All right, Professor.
Yes, Chirag.
So I have like not about the content of the exam, but like questions about like the procedure.
Mhm.
So we're allowed to have one sheet of like a cheat sheet, right?
Mhm.
But if we print the Mips screen sheet, does that count as our one sheet or?
No. That's a separate one. That's optional. You can print it. You can have it handy in case that online document doesn't load up in your environment. So that would be a good backup for you.
Okay. And so the exam will be in a lockdown browser, but do we have to be on the Zoom call as well?
No, you don't have to be on the Zoom call. If you have any question, you just dial in or just connect to any other devices in the Zoom meeting, ask me question and leave.
Okay.
You don't need to be logged in.
Okay, makes sense. Thanks.
All right.
Professor,
Yes, Adam.
I had a question about problem set lecture 5 in module 4.
Problem set. Okay, let me just go there. Okay, which module you said?
Question 3, part B.
No, which module? Which module?
Module 4.
Module 4. Okay, module 4. Okay. Problem set. Okay, problem set. All right. Okay, all right. Question number 3. Do you see question number 3?
Yeah, part B.
Part B. Okay.
Mm-hmm.
Yeah.
So my question was, why is line 10 not a forward reference?
Line 10.
Yeah.
Oh, okay. Line 10 is actually resolving a label. Okay, it's a label. It is not what did they say? Okay, what was your what was the solution? Let me see. What was the solution given? Okay. I see you have a point there. Module 4, problem solution set. Let's see. Problem 3B. Three, 7, 8. This one, line 10, it should be a forward reference as well. You're right. Hey, thank you very much for spotting it. Like this is line number 10 is referring to a label which is not defined yet in the sequence. So symbol table doesn't have it, and thus it becomes a forward reference. Similar with a similar logic at 3, 4, 5, right? 3, 4, 5 has the forward reference. Excuse me. Excuse me. 3, 4, 5. Right. 7, 8. Let's see. 3 is looking for V1, V2. Okay. 5 is main L1, not defined yet. Then 7 V1, not defined 8. J main L2, not defined 8. Yeah, I think that was a mistake. We need to include 10, line number 10 as well there.
Okay, thank you.
Let me just note it down so that I can just fix it. So this is problem set 5 to 12, Q3, B. All right. What's next?
Oh, yeah. Okay, yeah, go ahead.
Go ahead, you go ahead. My question real quick.
Okay. So Professor, for the types of questions that are like trying to translate some machine code into, or sorry, assembly code into like a higher level of code, or like approximating which loop or like if statement would be like best modeled by it. Like for example, I think there was some on quiz 3, like question 10.
Okay. Quiz 3. So number 10. Okay, so what is the most appropriate high level C? Okay, block for this guy, right? Yeah, for this one.
Yeah.
Yeah.
So since like some of the loops are very similar, like you just need to kind of change one line around. Like the only major difference I saw was between the for loop and the do while loop, because, or like the do while loop, because it branches before like altering information, right? So in a lot of cases, isn't it kind of like ambiguous? Like how would you rule out, like how would you go through like exactly and determine the right answer?
Yeah, so I see it in this way, right? Like if something I can actually write with a for loop in a program, like a numeric for loop, rather to say, then it is I go with that. Otherwise, a while loop. Do while is more like you first execute that part and then decide to branch loop or not. And if then else is basically just two sequence of forward facing code, like forward. It's more like in your next instructions are always ahead of this test and jump. So that kind of an if then loop. Only looping back has this question of for and while. So ambiguity would be between a for loop and a while loop. So if it is a numeric testing, which is most of the cases it is for inside this assembly, it is a for loop.
Okay. That, I think that makes sense. So like for question 10 then, it would, since it has a branch to the end, so it can't be like an if state. It's between for and while, right? And then
Yes, it's between for and while. If then else is always forward executing blocks. Only the loops actually you see there is a jump back into some previous statement. So that's a looping. Now the looping between for while or do while is mostly marked as you don't have that upfront check and jump, but you go into that and then towards the end you have test and jump back. So that is more like a do while loop. You do first, then check the condition, then either branch out, go to the forward next instruction, or jump back. That becomes your do while loop. And this example is clearly like from line 7 on this question, line 7. Maybe I can share that window with you guys. Yeah, this one, right? So in this problem, this one is like more like this part is going back, jumping back from 7 to 3. So this is more like an either for or while loop. And for loop, I mostly put if it is, I see there is a test and some that test variables, right? T0 is basically used as an index, right? This is not operated on anyone else. It is not changed. This is more like an indexing. It is just by itself keeping track of the number of iteration. That part, it becomes an for loop. But if I see that T0, this guy is a product of many other operations like these and that, you do some subtraction, multiplication, other than just indexing kind of usage, that is more appropriate for the while too.
Okay, so it's like kind of a thin line where they could both have some operations like in the body.
Exactly, right? So you know that the high level, you can always make an for loop with a while.
Yeah.
No problem, right? They're kind of synonymous. But characteristics of for loop in general, like numeric, there is an index involved and you are changing that index throughout. Yeah, of course, there are other high-level abstract for concept where you probably don't need index there, like some 3 statement, and you somehow manipulate them. That's a different discussion, but let's keep our life simple on the for loop. Say indexing through the loop is a counting loop, and we treat them with that, like that.
Okay, yeah, that makes sense.
Oh, hi, Professor.
Yes, Ian.
Yeah, I have a question from set of problem from lecture 1 and 2, number 3A. So basically the question is ask how we count like how many address port from a word memory device from 32 gig. The answer is 32 gig divided by 4 gigabyte. Or where the 4 gigabyte come from?
Okay, just yeah, let me review that problem first. It's module 1, you said?
Yeah, module 1, the problem set lecture 1 and 2 for number 3, question 1. Question 3, and the A question.
Okay. All right. So this is the problem you were asking for, right?
Yeah, the A. So the answer she said that is 32 gigabyte divided by 4 gigabyte. I just wonder where the 4 gigabyte come from.
Okay, let me see. What is the problem? 64-bit computing system is connected to a word addressable memory, okay, size of 32 gigabyte, which has 32 bidirectional data pin. This memory need 1 clock cycle, etc. How many address ports and pins are there in the memory device? Okay. So this is a word addressable memory, right? So that means each of the address is a complete word. It's not a byte. It's a complete word, which is a 4 byte, right?
Yeah.
That means if your memory is 32 gigabyte and each address contains 4 byte, then how many addresses you have? 32 gigabyte by 4 byte, right?
Yeah.
Then it gives you the 8G, 8 giga, which is like 2 to the power 33 addresses to be generated uniquely. So that means you need log base 2 of that, which is 33 bit.
Okay, I got it. And the other question, if the system is half word addressable memory, should it be divided by 4 2 byte?
Half word addressable would be 2 byte, yes.
Okay, got it. Thank you very much. That's all my questions.
Okay. So what else?
Professor?
Yes, Karen.
I have a question about the jump and link instruction.
Mm-hmm.
So Could you pull up like the Mips green sheet?
Okay, sure. Okay. Where's my green sheet? Yes, let me share it. Yes, get it.
So for the jumping link instruction, scroll up. It's like, so it says, so doesn't the jumping link instruction store the next, I guess, instruction in memory into like the return address, which is PC plus 4?
Yes, PC.
But why is it PC plus 8?
Oh, that's a good question. That's a good question. PC plus 8. Or 31. It has to be the next instruction. Okay, I don't know why this is 8, but I'll try to find out, okay? I never noticed that. It should be PC plus 4 because that's the next address is you need to come back by JR of RA. I think RA is 31. RA is 31. So PC plus 4. Why it is another 4? Okay. Jump and link. Okay, I'll take a look. I'll probably put that question in the discussion. Okay.
Okay, thank you.
Why jump and link has R31 equals PC plus 8? Okay. Okay. I'll take a look up and see. All right. Anything else?
I have a question.
Yes.
Could you talk about the difference between when it's reserved for kernel operation and hardware operation?
What is reserved for what?
Kernel operation and reserved for hardware operation?
Not really. I haven't talked much about that one. Any specific question on that side?
There was a quiz question that showed like where the dynamic data and the static data is stored, and then there's the reserved at the very bottom, the memory layout. And it says the reserved is for hardware operation.
Right. Yes.
Could you like go in more in depth about what that means?
Okay, that's an interesting question. So let's keep it for CS147. So in a nutshell, it is used for virtual memory implementation, and which is too complex at this point. Okay, just keep that in mind. That reserve space is for the hardware operations, for the virtual memories, and we'll talk in details almost towards end of the 147 on that.
Okay, so for $K0 and $K1, it's reserved for kernel operations, correct?
Right.
So what exactly are kernel operations?
Kernel operations are the operating system software's code. Okay, so when you are running a system, you first boot up an operating system, right? Whether it is Windows, Linux, or any other, whatever operating system you love, Apple OS, for example. What it is operating system? Operating system is a software program running on top of the hardware, which control the resources for the user program. So one software program always runs on a system, which is operating system. You may not initiate running another browser or any other program or compiler or Java machine or anything else, but at least one program fundamentally runs on a system. That's the operating system. Operating system itself is a software program, but it's a special software program, and it has a special privileges, and it has special calls reserved for the kernel operations and operating system usage. So kernel operations is more like, we are talking about operating system kernel code. More will be coming on your operating system class on that. So this is a good question. Keep them in mind. We won't be dealing with that in this class in details. Just to mention, these are two registers specifically reserved for these OS operating system kernel code to use. Okay, makes sense. I know you won't be satisfied with this answer, but it is out of our scope, Kevin.
Okay, thank you.
Okay, so by the way, in this class you can use K0, K1, like no problem. Okay, but by convention we should not use it. But no one is preventing you not to use it in this class, in this course, especially when you are writing direct assembly program. Okay, maybe Mars will complain a little bit. Maybe Mars uses that assembler temporary and the kernel for this own purpose, own simulation purpose, but that's not the point. Point is, when you are programming at this very low level with the assembly language, you can use any register. Okay, but by convention we are restricting it, that don't use K0, K1, etc. on this. Okay. All right, what else? Okay, if there is nothing else, then let me stop tonight. Good luck on your midterm. I'll keep an eye on your discussion, midterm question. Any other question arises, please put there. I will try to answer on the discussion board, and I'll try to find out this JL, why this is PC plus 8. I'll try to put an explanation there as well. Keep an eye on that. All right, good night, everybody. And
thank you, Professor.
Oh, make sure your programming assignment 7 is due tonight. Make sure you don't forget about that in midst of all these midterm things. Okay. All right. Good night.
Good night, Professor.